let's start with the list. So what is a list? So a list has certain characteristics, but to best understand it, I'll state the most obvious characteristic the list has is that a list is an interface. So list is an interface. So if you think about it in terms of the Java language, where we have classes, we have interfaces, we have enums, enumeration types, we have several types within the language. A list is an interface type. So that is foundationally what it is. And what that means for us is that a list will likely contain abstract methods. These are methods that don't have an implementation, and it will contain perhaps default methods that we looked at on our interfaces recap. So those are the things that we expect a list to have. And it being a list, an interface, we also expect that there should be an implementation. So this depends on implementations. So you need an implementation for you to work with a list. Because it's an interface, the methods that are declared there don't have an implementation. So you have to find an implementation or create your own implementation. So just like we saw with the collection interface, we had to implement the interface. Using this implements keyword, we had to implement the interface, which gave us the abstract methods that are declared in the collection interface, and we provided functionality for those methods. And if there were any methods that we were not able to provide functionality for, we threw this unsupported operation exception. So in terms of language level, within the Java language, a list is just like a collection is an interface, which means it contains abstract methods. It might contain some default methods, which means they come with some default behavior. And also it depends on an implementation. So you have to have an implementation. So from OOP, these implementations are also referred to as concrete classes. So you need a concrete class. You can think of our freezer collection as a concrete class. So this freezer collection is a concrete class for the collection interface. It has implemented the abstract methods within that interface. The other thing that we need to remember is if this list interface has, because the list interface has abstract methods, the concrete class, the ones that implement this interface, they might decide not to support some operations. And just like us, that's why we started with trying to implement our own, some of the interfaces that are available. So just like we did with the methods we were not able to support, we'll just trigger an error. And the most common error that's used is unsupported operation exception. So anytime we are trying to use these concrete classes or implementations of this list interface, and we run into unsupported operation exception, we should know in the back of our minds that that just means our implementation doesn't support that method, although it's declared in the list interface. So I think with that, we probably have, at the language level, we have a clear view of what a list interface should be. So in terms of data structures and algorithms, what is a list? So a list wraps, it has the capability of wrapping a dynamic array. So the same way we did with freezer collection, you'll find a lot of similarities with what we did last time. If you look at the implementations of lists, you'll find that they are housing an array one way or the other. So it wraps an array, but the difference between that array and the one we implemented for our freezer collection is that that array is dynamic. So the array that we used here is fixed size. It's not dynamic. We don't have functionality within our freezer collection to expand this array. And that is why expand or contract it, whichever direction. If it is initialized with these elements, if those are 10 elements or 5 elements, we are limited to those 5 elements during the lifetime of that freezer collection. We can't change it. And that is why, if you look at some of the methods we were not able to support, it was this add function that's supposed to add new elements into the freezer collection, a remove function which is supposed to remove elements from the freezer collection. So if you're adding, you have to expand the array. So if it was 5 elements, you need to move to 6 elements. We're not able to support that because our array is fixed size. So the concrete implementations for the list interface, majority of them, I believe perhaps most of them, have support for dynamic array, which means the size can change. So you can keep adding elements and the implementation will handle that dynamic nature. They also use something called insertion order. So insertion order means the elements are stored in the order in which they're added. So that is something that will become important as we go forward. But the other one that we can borrow from what we've done is that they are indexed. They are index based. So I remember when we were looking at this freezer iterator, and we actually had a few problems here, and we were able to solve them by making sure that we match the index of the array correctly. And because I've told you guys the concrete implementations of that list interface wrap a dynamic array, and the way you reference elements in an array is through indexing. So when you're working with any concrete implementation of list, you'll notice that you can use index-based access, just like we were doing. So index-based access just means you can reference the array itself and then pass an index, and that index will give you the element. So call back to the arrays class. So the same behavior is borrowed by list interfaces. So since they're index-based, the other thing you need to know is that they're zero indexed, which means the indexing starts from 0. So if you guys remember from the previous class, this means if you have an array that contains 3 letters, 3 characters, this array, the index of the first element, which is A, this index will be index 0, not index 1. So this will be at 0, this will be at 1, and this will be at 2. So that's what we mean by zero-based indexing. So when you're accessing elements from a list, just like when you're accessing elements from an array, you have to keep in mind that the first element will be at index 0, not index 1. Very important. As we saw last time, we ignored that for a bit, and we were able to see that triggered some errors to emerge. So to avoid covering too much theory, maybe let me state the last property that we need to be familiar with. So here we are talking about lists. The other thing is it allows duplicates. So within a list, you can have A at index 0, you can have B at index 1, you can have C at index 2, and you can have again B at index 3, you can have another A at index 4 in this case. So it allows for duplicates. You can have duplicate elements. The other thing that lists allow is they allow nulls. So you don't need to worry about null. So allows nulls. So you can pass in a null into a list and you'll not have a problem. So you, just like with our example here, let me just copy what we have. So within this this same list, you can have at index 5, you can have a null value. So you can have null, and this is a null at index 5. So it allows duplicates and it allows nulls. There are other collections that will find that they don't allow duplicates. And when we get to that, you'll be able to see the difference. So if you are writing a piece of software that is sensitive to your collection having null values, then you might want to avoid a list or have your own custom code that ensures that nulls are not inserted into the list. Okay, enough theory. Let's do something interesting, which is writing some code. So I'll just create a main method here for us to start exploring. And maybe before I go ahead, does anybody have a question regarding the theoretical concepts we've looked at for the list? Yes. Yeah, so Dennis is asking whether we are going to dive deep into the illustration or in the insertion order. So we are going to be able to see this with code samples. So I believe it's best demonstrated with code. When we do a sample, it will become more clear. The only theoretical thing that you need to remember from that insertion order point is that the retrieval order is not guaranteed. So so retrieval order is not guaranteed. So the same way you inserted the elements, when you're retrieving them, you will not be able to retrieve them always with the same order. It's not deterministic when you're retrieving. But during insertion, you can insert them in the order. They'll be arranged in the order you inserted them. So when you are retrieving by index, the same way you do with arrays, I want an element at index 0, I want an element at index 5, you'll be able to get the right element. But if you are doing a bulk retrieval, you are saying, give me all the elements that you have. When they are being returned, the order might be shuffled. And the reason for this is, although we are going to discuss it a bit more, is the dynamic nature. Because the array that, the collection that you're using, as you add the elements, that array keeps changing. That's why I'm saying we'll be able to see it when we do the code, okay?
Insertion order is guaranteed, so in line 11, if I add C3, it will come the last element.
Yes. So when you do get at, so let's see, line, you said line?
11.
Yeah, so if you say get 1, you'll get B. If you say give me the element at index 1, you'll get B. It will not give you 2. It will not give you C or A.
What if I add, so I add C3, it will go to the last type?
So if you add, so there are two ways you can add. You can add by specifying an index. So that will do some swapping for the values that are there. Depending on the method that you use. Also, if you add without specifying the index, then it will just make that the most recent added element, I think. Yeah, but we'll see this more with the code samples. Yeah, but that's a very important point. Thank you for asking. So that and the dynamic aspect and how it affects how you write code, those are very important, and we'll be able to visualize them well. So before we work with the lists, this is the problem here. If we want to create a list, like I said, you can find list in java.util.list, I believe, yeah. And you can see it's a generic type. So just as is our tradition in this class to look into the Java source code. So you see, a list is an interface, okay? We covered interfaces, so this is just an interface. So this is how it's implemented inside the language, and it's a generic interface, which means it can support multiple types, and it's not bounded, which means you can essentially pass anything here. And it extends sequenced collection. Sequenced collection just means we have an intermediary between us and the collection interface. So we were able to implement the collection interface directly. for us, what we did is we implemented the collection interface directly, but what sequence collections is it extends the collection interface, and then it adds abstract methods, some additional methods that we will discuss, we'll go through, and then now the list interface now implements that. So a list interface extends collection interface indirectly through an intermediary. The intermediary is sequenced collection. So the thing with interfaces is you cannot instantiate them directly. So if we said, and I expect for those of us who have been in this class, probably this is preaching to the choir. If I say a list, and this is my list, is equals to new list, I'll have a problem. I cannot do that because list is not a class. It requires us to have a concrete implementation for us to start using it. The same way we have the freezer iterator that implements the iterator. So you cannot instantiate iterator directly, but I expect that we know that already. So how are we going to be able to get a list? So the way you get a list is by using one of the available concrete types. You can use an array list, or you can use a linked list. There might be a more, but for this class we'll be looking at this too. Yes, anyone? I had a mic open. Is there a question? Okay. If you have a question, just interrupt me. I'll be able to tell from the mic, and I'll be able to answer. Also, if somebody sees a chat and you're able to unmute, let me know so that I can read it and respond. Yeah. Oh, okay, cool. Nice. So let's see. So the way you can create a list is by using one of these concrete types. So there's a survey that was done among Java developers, and the interesting thing is like 90% of Java developers use list amongst all the available collection classes, collection types. So within Java we have lists, we have queues, we have sets, we have maps, but the most used collection is the list. So we are starting from the sweet part of the cake. So this will be very important. If you have any questions, feel free to ask so that you get this. So for this, we'll be using one concrete implementation, which is ArrayList. Again, just like is our tradition in this class, we are going to peep into the Java language source code and try and see what is this ArrayList. So unlike the list, here, list is an interface, but ArrayList is a class, and that class implements list. ArrayList implements list. Of course, it implements a bunch of other things that are not important for us at this time, but the main thing is it implements the list. So if we create an array list, we can use that to instantiate a list. And of course, because it implements list, we can imagine there's some abstract method that's declared in list that is implemented here. So that, at least that we know. One thing I wanted you guys to see is, you see this is an array, right? If we go to our freezer collection, this is an array. So have that in the back of your minds. It will be important later. Okay, so then, so I've said we are going to use ArrayList. What is the difference between ArrayList and list? It might not be very important right now. What you might need to know is that the most important thing to know is ArrayList is an implementation of list. Linked list as well is an implementation of list. So if we go to, if we look for linked list, let's see what the Java language has. So you can see linked list is also a class, generic class, and we can see that it implements list, but it implements other things. most notably this, but you can ignore that for now. What we are focusing on is that it implements list, which means you can use it to initialize our own lists. Awesome. So let's go ahead and use ArrayList. So how do you instantiate using ArrayList? So the way you do this is, first of all, list is generic, which means we might need to specialize that to specify the type we want to store. So for this example that we are starting with, we just want to start simple and create a list of numbers. Let's say numbers. It will be integer numbers list. So it will be integers, but just let's call it numbers list. And this numbers list is going to be the parameterized type is going to be integer. So we've done generic. So when we talk about parameterized types, I believe I'm preaching to the choir. So then the next thing you do is just, of course, say new is equals to new array list. And voila, there you go. You have an array list. And that is our numbers list. So currently our numbers list is empty, but we would like to start doing some interesting things with it. So one thing I'm going to try and do is I'm going to try and check the size. So first of all, let's try and access some of the functions that we had in the freezer collection, just to see whether there is correlation. So let's see if we have size. So if I call numbers list dot size, size. Oh, I see there's a size function, and this should give us the size as int. So number of integers. If I want to, of course, I'm getting a lot of suggestions from the IDE here, but let's ignore them for now. So the other function we had is empty. So if I want to check whether it's empty, of course, that will give me a boolean is empty, and we can call numbers list number of integers dot is empty. Sorry, numbers list, which is the collection. Okay, just to avoid confusion, let me just call this list so that it's shorter and also I don't confuse it with the other variable. And I'll call is empty on it. What is the other function we had here? We had contains. Let's see if we can call contains, which also returns boolean. Contains list dot contains, and we can say, does it contain 45? 45. And we'll get a response. So this is the thing that you should notice is the functions that are available, that are declared abstract in the collection interface are now, yes? Okay. The functions that are declared in the collection interface are now available to us as within the list interface. And that is the consequence of the list interface also being an interface that extends from the collection interface. So that's why those functions are available there. So the inheritance hierarchy is you have the collection interface, then you go to the list interface, and then you go to the concrete type, which is array list, or in future we'll look at linked list. And you can see the functions that we are working with under freezer collection are now available to us. Let's go ahead and print some of this, so that we can be sure that our code works. So I'm going to try and get the size. So the size is available there. The other thing was whether it's empty. Is empty, and is empty is just that value of is empty, and I'll go ahead and print contains 45, and that will be contains. So if it contains 45, we expect this to print true. Is empty, we have not added anything to it. so we expect it to return false. Contains we expect to be false as well because we haven't added anything. And number of integers should be 0 because it doesn't have anything. So let's see what happens. So size is 0 as expected. Is empty is true because it doesn't contain anything. Contains 45 gives us the value of false. So it's working as expected. So it's working just the same way the freezer collection was working. So now let's try and add some elements. So how do you add elements? You add the elements by calling an add function. And there is a variety of add functions. There is add by index, and there is add where you just add the value. So the functions that are available are add, this add where you can add a value. Let's say I want to add the 45 that I was looking for. And there is list.add, which allows you to specify an index. So you can pass in an index here, and then you pass in the value. So let's say I wanted to add at index 0. So at index 0, and I want to add my value is 45. Yeah, so there's no problem if I use int here because of auto boxing, but I believe we learned that in the OOP class and when we're working with interfaces and partly through generics. So from the generics class, we know why we cannot say the type here is int, because generics does not support primitives. So I believe there we should be in the same page. So there's no problem if I do this because Java will automatically convert it to integer, and I don't need to worry about that. So you can add by index, and you can add the value itself. So so for this second add, let me try and just change it to another value, maybe 44, something different completely, maybe 11. And let's see what happens. So first of all, I'll disable this just to see if our initial add works. So we are just adding 45, and you add by calling list.add. And let's see if what we'll get for the value of the size is empty and contains. So I'll just run that. And now we see with that, the size of the list is 1 element because we only added 45. Is empty returns false now because it's not empty, it contains an element. And contains 45 returns true because we passed in the value 45. So just to make sure it's not a fluke, let's pass in 55. See whether contains will return a different value. So contains 45 is now returning false because it doesn't contain the value 55. So I'll just change this back to 45. And yeah. Any questions so far with the add function? Okay. So that's good. So let's see what happens when we add to an index. So we are telling the list that add this value, but I want you to add it at a very specific position. Particularly, I want you to add it at index 0. So let's run and see what we get from that. So now we see that the list contains 2 elements. Is empty returns false. Contains 45 is true. Let's see if it contains 11. So here contains, so let me just have 2 of them. So contains 45 and contains 11. And since you guys know what that does, I'll just call it inline here. Contains 11. I'll keep the contains 45. Perhaps I could so inline them. I can do contains 45. So this will check whether it contains 45, and this will check whether the list contains 11. And let's see. So contains 45 is true, contains 11 is true. So we know the values are there. What we don't know is whether the value 11 is at the index that we specified. So how can we tell? So that's where we go to the next feature of the collections, which is the ability to retrieve values. So with these two functions, we're able to add values. So this allows us to add elements to our list.